All right, lesson 2, proportional relationships and unit rate. Today we're going to be looking at these different statements, graphing proportional relationships, and interpreting our unit rate is what we're really going to work with today with slope. Using the graph and table, and I will try and answer some questions beforehand from yesterday's homework. In periods 8 and 9, I will put the answers up for you to check under the document camera for the sub, and then we will go through the lesson. So today, problem 1. You're going to be watching this video, so I'm going to put the video up for you right now. As you watch it, you're going to try and answer the question. And the question is, what's the unit rate? And then we're going to answer this and looking at the graph. So I'm going to put that video on for you right now.
Is this car traveling? What is the unit rate in miles per minute? In this lesson, you will learn to find a fractional unit rate by using a graph. You've already learned how to find a unit rate from a graph in some cases. For example, for this graph of a proportionate relationship, you could find 1 on the x-axis and see directly that 1 pound costs $3. So the unit rate here is $3 per pound. Now in this lesson, we're going to be needing to divide in some examples where we don't get an integer as an answer, such as what's 3 divided by 7. A common mistake is thinking that you always need to give your answer as a decimal. In fact, it's often much more efficient to give the answer as a fraction, because 3 divided by 7 can just be written as 3/7. Keeping that in mind, let's move on to see how that can help us find a unit rate from a graph. What's the unit rate for this proportional relationship? Well, the quickest way is often what I reviewed earlier, to just find 1 on the x-axis. The problem here, though, is that when we look up at the graph, we see that we're not on an integer. The y-coordinate corresponding to 1 as an x-coordinate is not a whole number, so we can't tell precisely what it is. Fortunately, we know a few other ways to find the unit rate. One way is to pick any ordered pair on the graph, such as this one, and look at its coordinates. This ordered pair tells us that in 5 minutes, you can travel 3 miles. 3 miles in 5 minutes. From that information, we can find the unit rate by dividing. And again, remember, fractions are just as good in this case as decimals, so our answer is 3/5 of a mile per minute.
So at this point, right now, we want to fill in our notes. So what was our unit rate? Well, they gave us that. 3 miles in 5 minutes is what you want to write down. So 3 miles, we are looking at our distance in miles, 3 in that 5 minutes. How do we answer that as our unit rate? We're going to leave it as 3/5 of a mile per minute. So please make sure you have these two filled in your notes. If you need to pause the video for students to write this down, please do so. Now, this next one, understanding proportional relationships, again, we're going to watch this video. And as you do this video, what you're going to notice is it goes on to this page and the bottom page in your notes, the next page in your notes. So, comparing the equation to the graph, do they show the same relationship? And so we're going to be looking at the costs again and the dollars. So I'm going to start the video for you. And as you look at this video again, keep in mind that you're trying to answer the questions as you do so. So as you look at this one,
Did you know that equations can have pictures? Here's a complicated equation, and here's a picture. You might study why this equation has this picture in high school. But for now, let's look at a simpler equation like this. What kind of picture does it have? In this lesson, you will learn to understand proportional relationships by relating their graphs and their equations. Let's review what you already know about equations for proportional relationships. Here's a proportional relationship, $8 for 2 pounds of potato salad. You already know that the unit rate can be found by dividing. In this case, it would be $4 per pound. To write an equation, you pick a variable for the independent quantity, which is the number of pounds. And you would need to multiply that variable by the unit rate, by 4. 4W would give you the cost of any number of pounds. You pick a second variable to represent the dependent variable, the cost in this case, and you set 4W in this case equal to that second variable. So the equation is that the cost is equal to 4 times the number of pounds. There are a couple of common mistakes we need to be careful about. Suppose you're talking about 3 miles per hour, and suppose you use t and d as your variables for time and distance. Which one is the independent variable? Which one goes on the x-axis? Well, in a unit rate, the one that is the after the word per, the one that we have one of, is the independent variable. It goes on the x-axis. 3 miles per 1 hour. So time, or the number of hours, goes on the x-axis. One more thing to be on the lookout for. If you're writing the equation, which of these is correct? Be really careful that you multiply the correct quantity by 3. In this case, we want to multiply the number of hours by 3.
Notice you are now on that second screen down as you are looking at problem 3 on your notes, so that you're looking at the same one.
So it's 3 miles per hour. So this is the correct equation. First, let's learn how to compare a graph and an equation to see if they're showing the same relationship. Here's an equation, c equals 4w, and here's a graph. There are a few ways to check whether they in fact show the same proportional relationship. One way, which is a bit slower, is to test specific ordered pairs. For example, here's an ordered pair on the graph, 2, 8.
Put this in your notes.
Plug those numbers into the equation. In this case, they do satisfy the equation. You should test a few more ordered pairs from the graph until you're satisfied that the graph and the equation represent the same ordered pairs. A different method is to use the unit rate. From the equation, we can see that the unit rate is 4 because it's the number that we're multiplying one variable by to get the other variable. Is 4 also the unit rate that we see when we look at the graph? Well, if we find 1 on the x-axis to see how much 1 pound costs, we see that it also comes out to 4. 1 pound costs $4. So both of these have the same unit rate, therefore they're the same proportional relationship.
On the bottom
We can
half
also
now,
talk about how to make the
page.
graph from the equation. 3 miles per hour, whose equation could be d equals 3t. T represents time and d represents distance. How can we make a graph of this proportional relationship? Well, you've already learned in the past that you can make a table of values.
Please put that table right below the d equals 3t in your notes. So right below this, please put time, hours, distance, miles, and put these 3 values. This is really our t time and d distance. So put those 3. Also, if you need to pause the video to plot the points, do that also.
And plot those values and connect them. But another way is to use the unit rate. From the equation we see, and from the statement 3 miles per hour, for both of those we see that the unit rate is 3 miles per hour. So we can use that to make the graph quickly.
The one thing you are going to notice that is in my table, I went with 0, 0. So if we were plotting unit rate 1, 3, 2, 6, 3, 9, you would have plotted those using your unit rate. We now have one more video that's going to do some comparing, and this will help you with your homework. We're going to be asked to do some comparisons. So watch the video, and these are going to be for the next 2 slides that you're doing. And so this is on that page with the video 4, as you are looking at this. You're going to see store B at the top. And we will be adding some other information to this page. So as you watch the video, just be sure you're going to be writing along with this. So as we do that, let's make sure, and here we go.
How can we compare prices represented in different ways? If I tell you that store A charges $2.50 per pound and store B charges $3 per pound, the comparison is easy. But if instead I give you a graph showing store B's pricing, how can we compare and decide which store is offering the better buy? In this lesson, you will learn to compare proportional relationships by comparing their unit rates. Let's review what we know about finding a unit rate. We know that if you have a pair of numbers, like $6 for 2 pounds, you can divide and get $3 per pound. We know that from an equation for a proportional relationship like C equals 3W, the number in the equation is the unit rate, so 3 here would be the unit rate. And we know several ways to find the unit rate from a graph. One of the easiest, when it's possible, is simply to find 1 on the x-axis. In this case, 1 pound corresponds to $3, so the unit rate is $3 per pound. When answering the type of question that we're going to answer in this lesson, we need to interpret numbers carefully. For example, which of these 2 stores offers the better buy? We can tell that $3.50 is less than $4. Do we want fewer dollars per pound, or do we want more dollars per pound? In this case, better buy means fewer dollars per pound, but we've got to be careful not to automatically pick the larger number or the smaller number without thinking the situation through. Okay, so which of these 2 stores offers the better buy? Store A's pricing is represented by this equation, and store B by this graph. Let's figure it out by comparing the unit rates. The unit rate for store A is $2.50. $2.50 per pound. Store B has a graph. We can find the unit rate by finding 1 on the x-axis. We see that 1 pound costs $2, so the unit rate is $2 per pound. Since we're talking about which is the better buy, the answer is going to be the store that offers, that costs fewer dollars per pound. So store B is the better buy, because $2 is less than $2.50.
Now go down to your next.
By the way, this is what the graph for store A's pricing would look like. Notice that it's steeper than store B's graph. That's because you're paying more dollars in store A for every pound. Which of these trains is traveling faster? Train A travels 8 miles in 5 minutes, and train B's distance and time are shown on this graph. Again, let's compare unit rates. For train A, we can divide 8 by 5, and we get 1.6 miles per minute. I gave this as a decimal rather than a fraction because decimals are going to be easier to compare. For train B, the easiest way is going to be to pick an ordered pair. Notice that if we looked at 1 on the x-axis, it's hard to tell what the corresponding coordinate is because we're between 1 and 2 on the y-axis. But with the ordered pair that I've highlighted here, we can see that 5 miles are traveled in 3 minutes. Dividing 5 by 3, we get a unit rate of 1.6 repeated miles per minute. Now compare.
So in this case, if we are finishing off which one should be going faster, the train A or train B, this is going at a faster rate. Now, you will be working on your homework in lesson E2, so please make sure you take a look at that. Again, if you need to go back and pause any of these in the video, go back so that everyone can get their notes filled in, and you should be ready for tomorrow when I come into class for lesson F3.